like to live on they typically like to live on the sea ice, but some places in the Arctic, they are forced to come onto land for a few months at a time. And this is just one of those periods where they're a little bit more on the coast. And what was so great about this photo, I took this photo in 2020 on Halloween. And of course, Halloween is a memorable day, but seeing these four polar bears and these three young cubs together was something for me that was quite memorable because in Churchill, it had been at least 15 years since either people who live in the town or researchers had seen a mom with three cubs at during the fall or around Halloween time. It's not usual anymore that a mom will have three cubs. And part of that has to do with the sea ice. So here, what we are seeing, what we were so excited about is it just shows us that there can be some mums and there are individual polar bears that are able to be very successful hunters out on the sea ice. And when they're successful hunting, they're going to be able to put on a lot of body fat. And when they put on a lot of body fat, particularly as a female polar bear, that means that she's probably going to be able to have more cubs. And that is really good for the population because then they're contributing to that population. So why was I in Churchill in 2020? Well, we have to back up a few years, and my slides are not advancing, and I'm not sure why. Oh, there we go. I started working with Polar Bears International over 10 years ago, and I was taking photographs, kind of like this one here, and then using my computer, I was drawing the yellow lines to take measurements. And so here are a few photos of me in the field, taking those photos. And what we were trying to do is Polar Bears International had all these great questions. We've researched polar bears in a variety of different ways, but about 10 to 15 years ago, a lot of the research meant we had to physically handle polar bears, or we just wouldn't get a lot of data. So we were looking for ways to not invasively, so just by taking photographs, collect data. And so what we tried to do is use, and this is me using the camera with these parallel lasers. And the idea was we could put these dots, like markers on the bear, and then I could, because I knew the distance between those lasers, I could then measure and then get these measurements of the bear. And these are all the measurements in yellow that researchers would collect when they are handling a polar bear, either in captivity or throughout the Arctic, to get ideas of how big they are, how much fat is on their body, and it really just gives us an overall indication of their health. But of course, that can be challenging sometimes. And so we were looking for those non-invasive ways. However, in Churchill, the pictures might suggest, it can get quite cold. It can be, and I am in Canada, so I know Celsius, but I believe the number I'm about to throw out is similar to Fahrenheit. It gets to about -40 sometimes in Churchill. That's kind of at its coldest in the fall. And the lasers didn't like that weather. They definitely work much better when it is maybe 60 to 70 degrees Fahrenheit, but not so much when it's below zero. And so we had to pivot. And so what we changed it to is I would still use a camera, but we would also use something called a laser rangefinder. And some people might be familiar with this. Golfers use it for calculating how far away the golf hole might be. Hunters might use it too to figure out, okay, how far away is an animal that they might be trying to catch, things like that. And what it does is it just gives us that physical distance between the camera and the subject, in my case, that polar bear. And so I'm able to triangulate the pixel measurements from the photo into real measurements that we can then relate to other polar bear populations to understand things like, are they getting smaller? Is there as much fat on them as there was last year? Or could we use it as baseline data to predict how much fat might be on polar bears in the future year? Because again, where I was in Churchill, Manitoba, bears come on shore and they're on land. Even though they are a marine mammal, they would probably prefer to stay out on the sea ice because that's where they're going to be able to hunt their food and get all the things that they need to survive. But they can go through long periods of what we call fasting. And that's what happens when they are on land. And Churchill is just, it's far north, but it's at the southern border of where polar bears are found in the Arctic. And so they have been spending more time on land, and it's approximately about 1 day longer each year. With the declining sea ice conditions that are happening in central Canada right now, which is again the southern part of the extent of the Arctic sea ice. And what I really want to highlight about this was one of my first introductions to research right after I finished some of my university courses, is that it was what we call citizen science. And so many visitors go to Churchill and they all want to take photos. And we just really we're thinking, well, we can turn all of those photos into data. And for a researcher, that's great because we want more data because then we can have more confidence in some of the things that we are doing or concluding. And it was a great idea to have myself and other students go out with the guests in Churchill to help collect some of this data, and with the hope that we could just take that photo and let one photo tell us a long story. So I'm sure you've all heard of a photo's worth 1,000 words, and sometimes that can definitely be true. If we are able to use that photogrammetric technique, we can get a lot of information on how big this bear was. So something that we end up with then is a variety of different photos, ideally in this type of profile where they're on their side, so that we can then see very easily where to measure. And I did all of that on my computer. And you probably are noticing here even that there's differences between this skinnier bear and this is a maybe more average bear. And then these ones down here seem to have a little bit more roundness to them. They're a little bit more fat. Being fat for a polar bear is actually a very good thing. That fat that they have on their body is stored energy. I like to think of polar bears as walking grocery stores. They just eat a lot in certain times of the year and they pack on the fat literally to their body. And then when there's times of the year where they can't find food, so when they're on shore and there's no seals on land, they love to eat seals. Or if they're hunting out on the sea ice and there's a period where there's just not a lot of seals around, they can mobilize the fat that they've stored on their body. And what I mean by that is just, okay, instead of eating food and putting it into their mouth and then into their stomach, their body will just start to take the fat and the nutrients that are stored in those the fat cells, to be the energy so that the bear can still walk around, bear's heart can still beat, and all of the things that living things need to do to be alive. And so when that happens, bears will start to look a little skinnier because then they're going to start to use some of that fat. And it's not a big concern when we see skinny bears. It's a fact of their life cycle, or a year in the life of a bear. There's going to be times of the year where they get really, really round, and then other times that they get skinny. What we as researchers love to do is we love to ask questions. And so a lot of the questions are, well, are the bears always skinny? Do the bears get skinnier faster? So earlier in the year, are they getting as fat as they used to? There's a bunch of questions like that that we try to answer through data like the photos you see here, or through other research methods of research. And so for polar bears, to just bring it back to these 6 photos, it's not super concerning to see skinny bears around Halloween because they're about to get to the point where they have used a lot of their fat. Like I mentioned, they are marine mammals that love to live out on the sea ice, and they would stay out on the sea ice year round if they could. But because in Churchill, they are forced ashore, if they come off the sea ice looking skinny, that might be a cause for concern, and it would start a lot of different questions like, are all the bears coming off the sea ice this skinny? Is this skinny bear skinnier than the skinniest bear we saw last year? Those types of questions, basically getting at their overall body condition, which is one of the main measures that scientists like to use to understand polar bear biology. And this is a tool that we use that can kind of help us score how fat is that polar bear, or how skinny is that polar bear. And so some of you might have seen a tool very similar to this. If you've ever taken your dog or your cat to the vet, vets use this for our pets at home. It's just a quick visual guide that helps us look at, okay, how big's the butt? How big's the stomach? And you just get an estimate, a gauge. And like I said, being fat or very fat for a polar bear it's an okay thing. They are specialized carnivores for a high fat diet. So what that means is their body will metabolize food very differently than you and I. They would not be able to do very well by eating vegetables, even though vegetables are very, very healthy for us. Our digestive tract, our gut, and the things that we eat, we need to eat vegetables or different things to get the nutrients we need. Their bodies require different types of nutrients and different kinds of minerals that are typically found in fats. And what's really great about marine fats is, I'm sure you might have even heard, like in commercials or from food industry, like there's omega-3s or omega-6s. These are a group of fats that are what we call unsaturated. And for polar bears, those unsaturated fats are easily incorporated into their body and stored on their body. So then that makes them that walking grocery store. So when then they don't have access to their food, they can just start using the fats that they've stored. And then what will happen is they'll kind of slide down the scale and start to appear skinnier. There's a lot of other questions that other researchers at this point might tie in. And so what I want to just mention is there's so many avenues in science that whatever you are interested about, I just want to take a minute and just encourage you to be curious, ask those questions, and follow that passion. We need questions to be asked for us to go and find the answers. My one little disclaimer will be that when you answer a question, more often than not, you are going to have 10 more questions that you didn't have before. So it's one of those things, like you feel like you take one step forward, but then you're like, oh, there's all these new unknowns. And that's the fascinating part about being in science. And for me, researching polar bears in the Arctic, it's just been this, I've not stopped asking questions. And so that is something that I just want to share with all of you, that you can even today start being a person in science. If you're a young woman or a girl, like science is here for you as well. All you need to be able to do is just start asking questions. And there's so many questions. I have focused more, what I'm going to say is more ecologic. So I look at interactions of polar bears with their environment or with other species. But for example, there's people that I've worked with that are much more specific on that metabolism or the diet and looking at the chemical component of a polar bear's body, which is super fascinating, and can be more fascinating to other people. And at this point, just because I've mentioned that they are lipivores, there's a whole area of chemistry devoted to understanding diets of animals. For me, like I said, I kind of thought more ecological. And so as I was like figuring out, okay, how fat are the polar bears in Churchill, which we knew overall there was a trend that shows that they're slightly average, maybe trending a little bit more onto the thin side. And that has to do with, again, the amount of time that they are able to spend on the sea ice. And with that knowledge that I gained during this project with Polar Bears International, it was like, great, we've answered a question. We know that we can take photos to look at their body condition. But then it just left us with like, is it just because polar bears are not on sea ice as long as maybe 30 years ago, which we know is true from some sea ice experts and some of the data that they have collected? And then we started thinking, well, what about what polar bears eat? And so for me, I started thinking about this diagram. And this is what we know as a food web. And so again, because I'm a more of an ecological perspective, I was really interested in how all of this interacted together. And so here we have, of course, the polar bear, which I've started our journey, my journey in science with. And now I'm starting to think about the seal. So seals are the polar bear's main food, but are like, were seals declining in body condition? Were seals in the Arctic in the same amount of numbers as before? Or was it really just because there was less sea ice that polar bears were getting thinner? And that question became very fascinating because we didn't have a clear answer to it. Seals are just kind of hard to study. As you can see in this image, they live in the water. They're often underwater. They only come out onto the sea ice in the spring when they are going to give birth to their pups. So those are the small seals that you might see pictures of in commercials and things like that. They give birth on top of the sea ice, and they'll also come out onto the sea ice and sit on top of the sea ice in the spring when they molt. And what I mean by that is they're going to grow new fur. And I actually do have a piece of seal fur that I know with my background it might be hard, but this is what seal fur looks like. This is just a strip of it. It's quite soft and it's really waterproof. Sorry, I'll try to hold it more in front of me so it doesn't keep blinking on and off. And this is from a ringed seal, and it gets its name because there's these very clear ring-looking patterns in their fur. But each year they'll grow new layers of fur, and in order to do that, they need to rest, and they'll come out onto the sea ice. So because of the fact that they're mostly in the water, they're kind of cryptic. We don't know a lot about them. It's been challenging to study. Other places in the world have been able to study them better. So it kind of started us thinking, okay, because polar bears eat ring seals, what do we know about them? What's happened to ring seals in the Arctic? We know that the ice is changing. We know that polar bear body condition is also changing and following similar trends with some of these declines. But what about the ring seals? And so I'm going to take us on a little bit of a trip to the high Arctic in Norway. So we're all the way kind of on the eastern hemisphere, and this island here is called Svalbard. So it's about between 78 degrees and 80 degrees north. So this is a place that if we were there right now, the people who live there haven't seen the sun in a few months. It's 6 months of darkness and then 6 months of light. And what I mean by that is we're used to the sun rising each morning and then setting in the night. When you're this high up in the Arctic, or if you're conversely ever that low near the Antarctic, you're just so close to the pole that when it's winter for North America, it's just completely in the darkness. The sun never really sets because of the Earth's rotation. But then conversely, in the summer, it's 24 hours of sunlight. So it will look like high noon, really bright, sunshiny day at 2 in the morning, which is usually not so great for your sleep pattern. How animals are able to live in that and rely on different environmental cues is something that people are still researching, because that's quite fascinating in its own self. But if we look back to this photo, something that I want to show you on this map or really highlight is there's two colors of lines that are coming away from Svalbard. And what researchers over there were able to do is look at where seals are going in the water. And we do that using these trackers. So I'll hold it like this first so that you can kind of see the size of my hand. It's not that big, and it has this really long antenna. This is a radio satellite tracker. So we put these on lots of different wild animals to look at where they go. So each one of those red and yellow lines is a single seal, and it's just showing us where it went. And in here is the battery pack. So it's batteries like you and I would have at home. They're just super, super, super charged. And then there's a little computer in here that's able to send the message through the antenna up to satellites in the sky and in outer space, then back down to researchers' computers, and we can plot where animals have gone. So this is something that would get glued on to the fur of the seal. So if I hold the fur like this, we would just glue, oh, sorry, with the background, it sometimes doesn't show. We would just glue it on. With polar bears, we are working on ways to do something similar, but up until now, we can get maps like this for where bears are using their radio collars. And so those collars will go around their neck. And unfortunately, I just don't have one with me in my office, but I had the satellite tracker of the seal, so I thought I would show that to kind of explain ways in which we can see where animals go. Because with some of the changes in the Arctic and the sea ice, with like the changing climate, some animal movement patterns have changed as well. And I do see that there's a really good question in the chat about different kinds of adaptations. So for polar bears and animals in the Arctic, like types of adaptations that what they're doing right now with in response to a changing climate is they're changing some of their behaviors. And so I'm gonna maybe answer it here with the seal, and then I can in a minute show a polar bear example. But if I just highlight all of the yellow lines, again, each line is an individual. One thing I want you to kind of notice, there's a difference between the red and the yellow. And so the yellow are all bunched together. And what that showed us is that all the seals are doing similar things. They're going to the same spot. And the other cool thing about or difference between the yellow and the red is all the yellow are really close to Svalbard or really close to the island, whereas the red lines go so far. Like there's this one seal that went all the way over here, and we really see different lines. We see seals doing different things. The yellow lines are from 20 years ago when the sea ice extent went much further, closer to Svalbard, and the yellow lines are from 10 years ago, or I'm sorry, I misspoke. The red lines are from 10 years ago when the sea ice didn't reach all the way down to Svalbard. So what we started noticing in the scientific community is animals are changing where they're going and some of their strategies. And why might they follow the ice or swim further to that sea ice edge? Because that's what we concluded. With this map, we noticed that seals are starting to travel much further, and they're following that sea ice edge. And that's just because that's where so much of the food that they need is. And so it was worth it for them to swim further, to invest the energy to go to eat something that had a lot of fat in it. So the fat that ends up in a polar bear's body actually starts out in the sea ice. And so if there's one thing that you will remember from today, other than stay curious, always ask questions, and then you've done your job as a researcher, as a scientist. The thing about the Arctic that I think is the coolest fact is that the sea ice is so much more than just a platform. So we look at these white lines, and that's just showing the extent of where the sea ice goes. It's not just this solid brick of water in ice. It's full of little holes where lots of little organisms, smaller than your pinky nail, like microscopic little organisms live. And we call that sea ice algae, or you might have heard of the word or heard of species called diatoms. They're so small, but they do something so important for the Arctic, and they go through what we call photosynthesis, which maybe you've heard of, and maybe you know what photosynthesis is, and that's changing sunlight into chemical energy, which the trees outside your window will do. All plants do this. But for the diatoms and the sea ice algae, instead of what they do is they actually produce all of the fat that everything in the Arctic food web eats. And so all the fat that we see in polar bear's body started in that sea ice. So it's one of the reasons why seals will spend so much energy to travel out to the sea ice, because that's where they can get most of their food and get really high quality food. If we look to this next map, this is now back kind of more North America focused. So again, I'm in Winnipeg, right where my mouse is kind of hovering right now, and Churchill, where most of the photos of the polar bears that I've worked with are here in Manitoba, so in Canada, and where we were just looking for Svalbard for context was way over here. So this is quite close to the North Pole, very high Arctic. And something that we are still looking for answers on are how are different areas of the Arctic responding to the environment? And so I'm seeing some questions about like what's the biggest threat facing polar bears? And a lot of that just has to do with the changing of the sea ice conditions. 30, 40 years ago, we used to have ice that would come all the way down into this large water body called Hudson Bay. It's always been a seasonal sea ice area. It's quite far south. If we think about the Arctic, this is like our Arctic basin. This is quite far south. So it's always had seasonal sea ice, meaning that ice will form and break up all within the same year. However, with in the last 20 to 30 years, what we've noticed is the sea ice is breaking up sooner, so more earlier into the spring and starting to form later into the fall winter. And what that does is it's increasing the amount of time that polar bears in this area, particularly of Hudson Bay, have to then come on land. And when they come on land, that's when they're the walking grocery store. They're not able to hunt food very easily. They might get a meal or two if they're lucky, but generally when they're on shore, they are trying to conserve their energy and they're using the fat that's stored on their body. Because again, if we think about the food web, they love to eat seals. They love to eat different marine mammals that have so much fat on their body. And it's that fat that then goes onto the polar bear's body. There's another question similar to like what's the biggest threat facing polar bears. So again, I think just kind of highlighting that it's really the sea ice. And when we have increased greenhouse gas emissions, there's two things that are happening. We're warming up the globe, but what happens in our atmosphere is with increased carbon dioxide, so kind of just outside of the atmosphere, out in outer space, is it forms what we call a heat trapping blanket, and it just keeps the heat in. And the sea ice is really important for us too. It's not just polar bears that need the sea ice. Sea ice for us as humans works as like an air conditioner. It moderates the overall global temperature. And so with carbon dioxide emissions, or when we're putting that into the atmosphere, it traps the heat and then it kind of speeds up that heating, because the more carbon dioxide that goes in, then what happens is it will start to melt the sea ice sooner, and sea ice is white. Water is blue, or when there's a big body of water, it almost looks black. White reflects light. Black or dark blue will actually absorb the light. So what's happening as we increase temperatures on Earth, we're also seeing that the sea ice can decline, but then we're kind of speeding it up a bit because then the water's getting warmer. And that's something that a lot of oceanographers and sea ice experts are looking at. And this, I can take a moment to highlight that even though I have focused my research on polar bears myself as a biologist, and I now teach biology, a lot of what I know has come from a collective effort from researchers who look at polar bear biology. I'm also now someone that looks at the ring seal biology, but we could have chemists, people that look at different chemicals that are in the water or chemicals that are in the sea ice. We need sea ice experts that deal a little bit more with physics and understanding atmosphere and relating it down. We also have oceanographers that will look very specifically at the water and at the ice. When we all come together, we have a much better understanding of what's going on in the Canadian Arctic, but then also in the United States Arctic. It's kind of all similar, but each region is responding to climate change a little bit differently. Okay, so I'm seeing some really fun questions now. So what I'm going to do is actually go back to a picture, the picture I started with, just because there's a good segue I can have here about the cubs. And the same three cubs here are the ones that are behind me. When polar bears are forced ashore and they have to like what we call fasting, or what I've been saying is when they're the walking grocery store, they're going to be using more of their fat. For this one female, this mom, she was able to hunt enough, get fat enough to be able to feed these three polar bears, the cubs. And in this photo, they're 10 months old. So at around Halloween, they're about 10 months, because we think, to make it easy on ourselves, we say polar bears are usually all born around New Year's Eve, because that's about the typical time that they will. And then those cubs will stay with mom for at least a year. And that's what we see here. So that's when they're 10 months old, and we'll call them the cub of year. They'll also stay with mom for one more year. So when they become what we call a yearling, and so they're about to get to their second birthday. Something that we are seeing, and to tie it into a couple questions that have been asked, like something I've personally seen as well, is some of the polar bear cubs in Churchill are now staying with their mom for another year. And the reason for that, it has lots of different implications, but one of the things I'll highlight is it tells us a couple of things, such as maybe mom didn't have enough time to teach her cubs how to be good hunters. And that might be because the sea ice was not in great condition. So if it melted really early one year, she needs more time to show her cubs how to be a polar bear, and she needs to train them how to hunt, so that they can get their own food when they're no longer with mom anymore. So typically polar bears used to stay with their mom up until their second birthday, and then mom would say, okay, it's time for you to be on your own. Goodbye. I'm gonna not give you food anymore. You have to go get your own. And then she would be able to go and actually mate again, and potentially even have cubs that next year. So what we've seen with sea ice declines is we've also seen that polar bears aren't mating as often anymore. But we're also noticing, one of the reasons for that is because some cubs are staying with their mom for more than 2 years. So I think I answered a couple questions there with something that I've personally seen over the last 10 years of going to Churchill. Again, each area where we study polar bears is a little bit different. And so it's really important that different researchers will focus on different areas and collect different data, because then we can all come together and share it. Some areas of the Arctic right now, polar bears are actually increasing in body size. And that's just because, again, what I mentioned about with sea ice decline, we are warming up some of the Arctic waters. And so we're in a one way making that area a little bit more productive. And so then the bears have a lot more fat to eat, but that might be a very short-term happy thing, like, or a bonus to them. It could, what we're looking at in the southern regions is baseline for what we can project in other areas if sea ice decline trends continue. There's another question about if they can see color. To be honest, I don't actually know the answer to this. I'm not sure if they can. I I don't think I've ever wondered that myself. I'm trying to even think if I know anything really about what they can see. I do know that they have a much better sense of smell. It is their strongest sense by far. They can smell seals up to 5 miles away, depending on how the wind blows. It might even be more than that. Um, they definitely follow their noses, and they are very curious with their noses, because that's just kind of what can lead them to their food. I don't know much about what they about their eyesight, to be honest. But it's really interesting to hear that sharks don't really see color. If I had to guess, I wouldn't. I wonder. Probably not. I don't know if color would really help them. I don't know if that would be an advantage to them or not. But I think that's a really cool question, and I've just never thought of that, particularly if they can see color or not. I'm seeing some other cool questions, and so I'm wondering if I'll just take kind of like a little bit of a break, and I can answer some of them about how much do they end up weighing. So I'll go back to this slide. Females are typically about 300 kilograms, or maybe 600 to 700 pounds when they're in their average to fat scale. When they get skinny, they can get down to like 200 to 400 pounds. That's not super sustainable, so we wouldn't want them to be 200 to 400 pounds year round. Males, so the big boys, we call them, they can get really large, and they can be up to like 1,200 to 1,500 pounds at their largest. I think the largest polar bear on record was just over 2,000 pounds, not kilograms, or slightly under it. It was right in around there. But what happens with polar bears is they have what we call sexual dimorphism. So it's not unusual that the males get so much bigger than the females. And that's often because the males will compete with one another so that they can mate with the female. And so the females don't put in as much energy into growing really, really, really big. They put in more of their energy into being with the cubs and that, so they don't need to be as large. The most significant danger that polar bears face when in the water, they don't really like to be in the water. They're not great swimmers. They definitely do swim. I've seen polar bears swim before. They are not good in it. Like dogs swim too. They kind of look like a dog in the water. They can't go very fast. The things that they eat, like the whales and the seals, are so much faster. So they would prefer not to be in the water. However, when they are in the water, I would say that the biggest danger for them is how long do they have to be in the water? Swimming around is going to take a lot more energy than walking. And so when they use their energy, they're going to start to get skinnier. And so if they use too much energy to swim, then that's probably going to be a cause for concern. We're going to be a little bit worried about how much energy they have to continue just being a bear or until their next meal. The longest recorded swim, I'm going to go back to my map because I'll show you where it was. So here's Alaska, and we have a few polar bear populations in the Alaskan part of the Arctic. So here in the Beaufort Sea, there was a female that had a radio collar, so similar to the seal tracker. Just think about it being then attached to a necklace, if you will. It was attached to a female, and she swam for 9 consecutive days for over 600 kilometers. And so that's the longest swim that we know of. Maybe they've swam longer than that. But if they didn't have a tracker on, we wouldn't know. So that's the longest recorded swim that we know of. And that happened, I can't remember the year off the top of my head right now, but it was within the last 20 years. And it's predicted that it was likely because she stayed out on the sea ice trying to get as much food as she could. And because of how the sea ice broke up that year and the trends of sea ice decline, it forced her to swim to shore for a much larger distance. So I'm seeing some questions about how many polar bears are there. And in the world today, we estimate that there's between 20 to 25,000 polar bears in what we call the circumpolar Arctic. So this is a great image for me to stay on because this blue dashed line that I'm trying to like draw a circle around with my mouse is what we call the Arctic Circle. And the pink line is what we also think of as Arctic or the tree line. So polar bears won't live inland. They'll live on the coastal regions or out on the sea ice itself. And throughout this Arctic, this vast space, there's 19 subpopulations. And so different researchers will research certain subpopulations. So the polar bears that I've been talking about and I've seen a lot, been fortunate to work with, the ones that are behind me, are in what we call the Western Hudson Bay population, and that's right here where my mouse is. So it's one of the most southern populations of polar bears. And studying them and figuring out how many there are can be tricky. So with different methods and different ways of knowing and tracking polar bears and learning about them, we feel that there's between 20 to 25,000. There's also questions about how often do polar bears attack humans. So again, in Churchill, Manitoba, If I just kind of go back to this photo, we are in a very safe vehicle. These vehicles, you could think of it as like a monster truck on wheels. Um, Sorry, like a school bus on monster truck wheels. You're very high because they can be 6 to 8 feet tall when they're standing on their back two legs. And that keeps us safe. In town, in Churchill, there's a lot of different ways to stay safe uh, for both bears and humans. And so that starts with just being aware when you walk outside, making sure you're looking both ways. And it's the joke it usually is like we're looking both ways to look for a bear, not necessarily a car. Um, so they don't often attack humans. I think what's going on and what a lot of us, there's more interactions happening nowadays because again they're being forced onto a shore. They're very curious animals and they have a strong sense of smell, and so we probably smell interesting to them, and they can wander into towns, they can wander close to garbage. I'm sure you've seen pictures of like black bears in campgrounds or even grizzly bears in campgrounds. Like those smells are just interesting, and for polar bears it's likely them just looking for food. Is this something I can eat? Is this something good? And they're not necessarily looking to attack a human. We don't have enough fat on our bodies, no matter what you might think. We don't have what they want. They really, really, really just want a lot of that high fat that really, sorry to go back to this picture, is found on the ring seal or a beluga. We don't have a lot of the nutrition that they are looking for, but we might smell interesting to them. And so it's not often that they attack humans, but there can be interactions that are not um, great. We want to make sure that all of those interactions are great in terms of safety for both us and the bear. So there's lots of different projects that Polar Bears International, again, are looking at. We love doing things non-invasively. And so we're helping with Churchill, for example. They have what we call the Polar Bear Alert Program. So they're people that will drive around looking for bears, getting close to town, and try to encourage them to go a different way. So we'll use different deterrents that don't harm the bear, but just kind of scare them or like make lots of flashes or noises. And then the bear's like, that doesn't look fun. I don't want to go there. And it helps them kind of, if they were following their nose and then they have this negative experience of some like bangers going off and loud noises, then maybe they'll think, oh, if I ever smell that again, I don't want to go near it because that wasn't so much fun the last time. So we have that program, but not all communities throughout the Arctic. Again, I'll go back to the map because I know it's, thinking about the Arctic, most people don't realize just the vastness of it. There's so many communities throughout Canada and the United States, even in Greenland, Svalbard, and then in the Russian Arctic that don't have the same supports or the same programming that Churchill does. And these are communities that typically didn't see polar bears coming into town as much. And now with the sea ice decline, they are, and we need new strategies. And so Polar Bears International is working on something like that in Churchill. It's called our Polar Bear Radar System. And you might be familiar with like the logistics of this, like a motion camera. Well, that's pretty much what it is, except it's a motion camera that's specifically designed for detecting a polar bear. So we are testing it in Churchill because there's polar bears around, and we can then tell the system that it's an artificial intelligence system. This is polar bear movement. This isn't a white dog. This isn't a white cat. This is a polar bear. This is something that you would, this is a real alert. And then that can help other communities be safe. So the question is, have you or another scientist ever had a close encounter when conducting your research? For me, one time I was doing research just outside of Churchill. I was actually looking at plants on the ground, so a completely different project. And about, I don't know, like 100 yards. So the length of a football field, there was a polar bear. And again, what we did is whenever you're working in the Arctic, where what we call polar bear country, you have a designated person who is your eyes. because when you're doing your work, you're busy and you're whatever you might be doing. And so we have dedicated people that will look and watch out for our safety, but also for the bears because we don't want them to come too close. And so yeah, there was about 100, I want to say 100 yards. It might have got a little closer, and we were just on foot. But again, we used those deterrents. You make some loud noises, and then usually the bear's like, that doesn't look like a seal, or that doesn't look like something I want to go investigate further. That just looks annoying or sounds annoying. And so that's my experience, but I know other researchers have maybe had closer calls. But again, you can't go and do research in the Arctic, particularly because of the polar bears, without a designated polar bear guard. And in some areas, you're even going to have local Inuit hunters come with you to, because they know the area so much more. They know polar bear behavior so much more than some of us that only go and visit the area, and they will keep us safe, and they help us interpret where the tracks are going and things like that, just again to keep us and the bears safe. So I'm just kind of going down through the questions because these are also great. And then if some of them help, I can jump to different images. So I'll go back to like my main one. So keep wondering, keep asking your questions. They're great. Are there anything that eat polar bears? And with this, it's hard to answer. Polar bears will eat other polar bears. We've seen that happen where if a bear dies, another bear might come and eat it. We've seen some bears eat a cub before. Like it's just kind of like it happens. Sometimes there's natural death that happens, and then depending on who's around in terms of what animals are around, they'll eat it. I've seen a raven eat at a carcass because ravens will eat at any carcass, really. Humans in the Canadian Arctic will have eaten polar bear for food. The only part of the polar bear that you cannot eat, and it's toxic, is their liver. Their liver, well, just like our liver, works to detoxify blood. So if you're ever eating something and there's something that's not great, like our liver is just filtering out all the bad things that we don't want to absorb into our bodies. Same thing is happening in the polar bear's liver, but it builds up vitamin A to such levels that are toxic if consumed. So no animal will ever eat polar bear liver, but they do have meat on their body, and so and fat. So depending on how fresh they might have passed or been killed by something in something that might have happened in nature, other bears will probably consume it, but they don't have natural predators. So there isn't something out there that will actively hunt a polar bear. They're what we call apex predators, or the top of the food chain. So killer whales are also at the top of the food chain, but they are exclusively in the water. So they are another apex predator in the Arctic. And the only predator, if you will, is not natural, but that would be humans. And we are definitely part of this food web. And in the Canadian Arctic, we play a really important role. Polar bears, seals, whales are very important in Inuit culture, and also for their own subsistence harvest for food. Polar bear lifespan. This is a really good question. So polar bears in the wild, I'll go back to this picture with the mom and the three cubs because it had something to do with age. This mom is probably around between probably 12 to 18. She could be as young as 5. So when they become females will become mature at age 5 or 6, and females will live up to about 25 years in the environment. Males will live less than that. Males will live maybe closer to like 16 to 20 years. And of course, they're all individuals, so some might live longer than that. The reason why females live longer, it's because of, I mentioned it a little bit earlier, males will fight each other for access to females, or maybe even over food. And they will fight each other very aggressively. We haven't really documented a lot of that because they're not going to fight each other a lot on land because there's nothing to fight over. But when they're out on the sea ice and there's a seal kill or a whale kill or females that are around, that's something that's really important to them, and that's something that they do want to defend or have access to. So they will fight. I do have a polar bear claw here, so I'm going to hold it up to the camera and you can, it's not super sharp because I've filed it down so that I don't hurt myself, but this is a real polar bear claw that I got from a naturally passed away polar bear here in Manitoba. And this claw, you can just see how hooked it is. And it's like a little knife that they have, and they have 10 of them on their front paws and then 10 on their back paws. They'll use these, of course, to catch seals, but it can cause a lot of damage if like they're hitting each other with the amount of muscle that they have on their body. Those sharp claws can do some damage. Their teeth can do some damage to each other as well. And so then they are just much more susceptible to wounds. And if they get infected, like any living thing, if you get an infection, it might be hard to recover. So males typically don't live as long. Polar bears have always been near and dear to my heart because growing up here in Winnipeg, Manitoba, we have a zoo, and at the zoo there was a polar bear. Her name was Debbie, and she is the longest living polar bear on record. She lived up to be 42 years old, and she passed away like maybe 15 years ago now. Maybe not even that long ago. So this was very recent, and she is the longest living polar bear that we know of. Again, that's on record. Polar bears will live longer in captivity because they don't have to fight each other for anything. They're given a lot of the stuff that they need, and so it's easier for them to live a little bit longer in those captive environments. Oh, here's a fun question as well. I'm seeing that there's a question about, do they have a sense of time? This is hard for me to answer or to interpret. I'm sure that they don't have a sense of time like maybe you and I do, where we're like, oh, it's 11 o'clock. It's time to do this. Or it's 1 o'clock. It's time to do that. For polar bears, it's probably more of a sense of time in terms of season. Most wild animals, I imagine, would have more of those seasonal cues. And so their timings are longer than that dictate the things that they need for life, maybe more so than you and I. So again, with polar bears living in the Arctic, and if you remember from when I was talking about Svalbard, and if I go back to that map, just to kind of, again, we're 78, 80 degrees north, really close to that North Pole. Here's that circumpolar Arctic. So like right here, they definitely would have a sense of, okay, it's the dark period, it's the light period, the sun's back. And that all interacts with when their food's available. In the springtime, there is so much sea ice and so much sea ice algae in the sea ice. And so we're going to have a lot of fish, a lot of the invertebrates, a lot of the things that are the bottom of the food chain that seals and whales are eating that the bears are then going to be able to eat. So they definitely will have a sense of that. And it's probably just the thing that the mom is teaching them too, like something about, okay, there's this much sun. We know that some birds rely on the night sky, so the star patterns, which also rotate through seasons. So I'm sure that they have some kind of sense of time. It's just maybe not like a 24-hour clock the way you and I run our lives. For them, it's probably much more of a seasonal clock. And I see another question in the chat that I think is really great. And I see I have a few minutes left, and maybe this is how I can end. How close are polar bears to extinction? So we get this question a lot with at Polar Bears International, like what's their biggest threat? And so I've been mentioning climate change and the decline in sea ice, again, really hoping that you'll remember that sea ice is so much more than a platform. It's where it lives. We think of the sea ice the same way as soil to a forest, in that sea ice is growing all of the nutrients that fuel the entire Arctic. So why are there Arctic fish? Why are there seals? Why are there polar bears? Why are there whales? Why are there people in the Arctic? It's because of the sea ice and what's in the sea ice. And trends with, again, climatologists and oceanographers, so people that look more at the environment physically, have gathered data that do show how it's warming up and there's changes. So we've seen some species just move their patterns, move areas, things like that. And it can sometimes feel overwhelming. Like, how do we stop this? How do we stop this? And there's just so many different solutions. And one of those solutions is really what we've been doing for the last hour. And we've been talking about it together and recognizing that we're part of the system too. So one of the things that we do at Polar Bears International is we think about how can we conserve polar bears, and it's not just for the polar bears, but it's also for ourselves. We're conserving our home and their home together. So when we think about extinction, there's 19 different subpopulations and they all are going through different types of trends. Some of them are on a decline, and it has to do with, again, that sea ice accessibility, because the longer that they're off the sea ice, the less body fat that they're going to have on their body. But I remember 10 years ago when I first started my journey is into what I now realize is a forever student, which I love being, 'cause there's so many questions. When I was doing this project and documenting changes in condition and relating it to sea ice, I remember talking to a sea ice expert, and she's at the University of Washington, and she just said, "Don't think of it as like there's nothing we can do. Sea ice is so dynamic. It's so much different than other environments." And she related it to a tropical forest where if we cut down the rainforest, it can take centuries for it to grow up again and become the environment that it once was. With the sea ice, there's models that show how the sea ice extent can change dramatically. We've seen it decline, but it can also bounce back. It's this very dynamic system, and we have some of the solutions with different emission targets and things like that. So there's models out there that do show and give me the hope that the sea ice is not all completely lost, and there is definitely still hope for conserving polar bears. And really, what we're doing today is step one. Talking about it, asking questions would be step two. Um, and I just want to let you all know too, just given the topic of today and like thinking about how you can protect biodiversity, is maybe polar bears are cool to you, but they're not like the thing you're most fascinated about, and that is absolutely okay. Whatever you are most fascinated about, I would encourage you to never stop asking questions and just stay curious, because that's when we're going to come together and make a lot of change. A lot of what we've done at Polar Bears International and what I do at the university is try to bring in a lot of different perspectives.
Well, thank you so much for your whole entire presentation. I think that's all we have time for today, but we really appreciate you and everything that you do. So thank you so much.
Thank you.
Have a great rest of your day.
You as well.
Bye.